Ich darf begrüßen Annett Heilmann. Sie ist Diplom-Ingenieurin für Biomedizintechnik und als Key Account Managerin im Bereich Strahlensterilisation bereits seit 25 Jahren bei BGS tätig und auch Mitglied im Nationalen Normenausschuss Medizin. Bei uns ist auch Barbara Schmitz. Sie ist Diplom-Ökonomin, seit über 30 Jahren in verschiedenen Bereichen der Medizin und Medizintechnik unterwegs und bei BGS als Key Account Managerin im Bereich der Strahlensterilisation. Die erste Session werden wir auf Englisch hören von Ihnen. Das sind sogenannte Mini-Pitches und da geht es erstmal tatsächlich um Grundlagen. First, Annett and Barbara prepared a quick pitch overview of methods of radiation sterilization. Please, ladies.
Thank you very much for your kind introduction, and from our side as well, a very warm welcome to our presentation, Methods of Irradiation Sterilization. Annett and I will guide you through this today, so let's begin.
Yeah, well, let's start. Single-use medical devices for diagnostics and therapy have to be sterile in many cases during usage. And in such cases, the sterilization process always represents the final manufacturing step. Several sterilization methods are available to bring products into this sterile state. And today, we want to briefly cover all of them, and later on, we will focus on radiation sterilization. Three main processes are used industrial on a large scale, and these three technologies are, first of all, radiation sterilization, ethylene oxide sterilization, and sterilization with moist heat. Sterilization can be carried out by using chemical procedures and exposing products and devices to ethylene oxide or heat. And these procedures are in principle also understood as classical surface sterilization methods. In contrary to this, the complete product is penetrated during radiation sterilization. This is the main difference. Irradiation causes damages of the DNA molecules in microorganisms. This is the principle of this technology. And in this way, as a result, they reliably lose their ability to reproduce, and consequently microorganisms die. The devices become sterile. First of all, let's consider gamma irradiation. Historically, gamma irradiation has been the most established process in the market. Due to this long application, the experience with regard to the effects of irradiation on materials and product properties is very, very comprehensive. Gamma rays are created through the decay of a radioactive isotope, and for gamma irradiation, this is cobalt-60, and cobalt-60 is used worldwide. The radiation emitted have a high penetration depth and penetrate entire pellets. Different plant concepts are available on the market, and coming to that, we consider as main part of such an gamma plant the so-called source rack. And here we have so-called source pencils, and these are arranged in such a source rack and integrated into a specific setup. It can be a flat one or a cycle one. And we create, with help of this, a unique radiation field. And products to be sterilized are transported through this radiation field via a fixed pre-specified path. In the process, the necessary radiation dose is applied on the product. Common dose ranges in terms of gamma irradiation to achieve sterility is around 20 to 50 kilogray, and the irradiation time takes several hours.
Let's consider eBeam irradiation. What does that mean? Electrons are admitted in a hot cathode and then accelerated to a very high velocity in a high vacuum by means of a strong electric field. And upon leaving the accelerator, the electron beam is deflected by a magnetic field onto the product in lines at a high frequency. The common dose range for achieving sterility is approximately starting at 20 kilogray, and with respect to the maximum dose, is set a bit higher than for gamma irradiation, namely at Dmax larger than 50 kilogray. The penetration capability of accelerated electrons is lower than for gamma irradiation, and due to that, the irradiation unit is always, for example, a cardboard box. The irradiation time with eBeam irradiation takes only a few seconds.
All right. After gamma irradiation and eBeam technology, we would like to have a final deeper insight to X-ray technology. What does that mean? Historically, we can mention this is the newest technology, and it is particularly suitable for the development of new medical devices and new products. To generate X-rays, a powerful electron accelerator is mandatory. The electron beam so generated is fired at a heavy metal target, and we create with that help Bremsstrahlung, which is used for this product irradiation. Compared to gamma, the dose ranges are quite similar and are between approximately 20 to 50 kilogray as well. Pellets can also be irradiated using this method, and the cycle time is also pretty similar to gamma.
Let's consider competitors and advantages. The validation of all three methods, gamma irradiation, eBeam irradiation, and X-ray irradiation, all of these three methods are regulated by standard DIN EN ISO 11137. And the only release parameter for all these three technologies is the applied dose into the product. The products can be placed in the market directly after the treatment, so that means a significant time saving for you as a customer. And the sterilization time for all three methods is relatively short overall. What can we hand out to you as a conclusion? As you probably know, in the area of medical devices, for example, the use of sterile products and medical disposable is a matter of course. Medical devices are today multifunctional and are manufactured from a very wide variety of materials. Despite their frequently complex geometrical structures, every part of them has to be sterile, as you probably know. The requirements for sterility are established by a number of standards, a number of laws, and a number of regulations. And in the biosciences and pharmacy too, sterile materials and equipment are indispensable for research and processing. So thank you very much for your attention. Thank you very much for your interest.
Thank you, Annette and Barbara, at this point for this quick wrap-up. And we have some questions popping up from our listeners. And first one, very easy. Does a sterilization procedure need to be validated?
A very clear yes, of course. It is a matter of medical devices and IVDs that are to be placed in the market labeled as sterile, yes.
So, simple question, simple answer.
Yeah.
All right. Can procedures be easily changed since that standard for this type of sterilization procedure is identical? Second question.
In principle, it is easiest to change the sterilization process within the technology radiation sterilization. But nevertheless, if you're going to change your sterilization technology, in general, you always need to have this change evaluated, validated, and qualified. And this is part of the change management.
Okay, thank you. And we have one additional question. Does BGS offer all three procedures that you mentioned?
Yeah, BTS offers two of them. It is beta and gamma irradiation as the, from the historical perspective, longer established methods in the market. Yeah, and X-ray is some technology, as I said, it is quite new and we are considering this very carefully and maybe this is a technology for future.
For the future. Okay. Thank you again. At this time, our both Annett and Barbara. And you stay with us. Und zwar auf Deutsch wieder. Wir haben ein Segment, das wir genannt haben, optimierte Logistik und reduzierte Komplexität, Chancen und Grenzen von Bearbeitungsklassen. Dem Thema wollen wir uns gleich widmen. Aber wir hatten ja eingangs, Sie erinnern sich, eine Frage über Slido gestellt und die lautete, aus welcher Branche kommen Sie denn? Und ich bin mal gespannt, ob wir das mal einblenden können, ob die Dinge im Moment schon präsent sind und wir uns das ganz kurz ansehen können, bevor wir die beiden dann wieder zum Vortrag bitten. Aus welcher Branche kommen Sie? Unser Polling bei Slido. Erste Publikumsfrage. Ich kann es hier auf dem Screen gerade nicht sehen, aber das ist, jetzt haben wir es. Wunderbar. Also, Medical Technology, Kunststoffverarbeitung, Medical Devices, Medizinprodukte, Medizintechnik, Medical Dental Drug Delivery, Electron Beam Accelerator, chemische Industrie, MedTech, Elastomere, Injection Molding. Also, spannend, all over the place. Cable haben wir auch. Das ist so ein bisschen das Thema, was wir dann morgen sicherlich haben. Bei der Strahlenvernetzung sehr stark. Laborbranche, Caps and Closures, ebenfalls ein Thema möglicherweise für morgen. Aber interessant, toll, dass Sie alle dabei sind. Wir freuen uns darüber sehr und bleiben Sie bei uns heute und morgen bei den Irradiation Service Days.